Welcome to this video on email and application layer protocol. Email or electronic mail is one of the most common and essential applications of the internet today. It enables users to send and receive digital messages quickly, reliably, and efficiently across multiple computers. In this section, we will explore the architecture of email through four key scenarios, illustrating how messages are sent, received, and stored in different situations. The first scenario demonstrates how a user sends an email from their client to the local mail server using SMTP. The mail server then processes and queues the messages for delivery. The sender and the receiver of the email are users on the same mail server. They are directly connected to a shared mail server. The admin has created a mailbox to store the received messages. Only the sender or the receiver of the mailbox has access to it. When Alice needs to send a message to Bob, she runs a user agent or a program to prepare the message and store it in Bob's mailbox. The message has the sender and receiver mailbox addresses. Bob can retrieve and read the contents of this mailbox at his convenience using a web browser or other user agent. In the second scenario, the sender and the receiver of the email are on two different mail servers requiring the message to be transmitted over the internet. Here we need both user agents and message transfer agents to handle communication. Alice, the sender, uses a user agent to compose and send her message to her local mail server. The mail server at Alice's side uses a queue or buffer to temporarily store messages waiting to be sent to the receiver server. On the receiver side, POP uses a user agent to retrieve messages stored in his mailbox at his mail server. Between the servers, two message transfer agents are involved, a client message transfer agent and a server message transfer agent. The server message transfer agent must run continuously since it cannot predict when a connection request will arrive from another client. The client mail transfer agent, however, is triggered whenever a message is readily in the queue, initiating the transfer to the receiver's server. This setup ensures that messages are reliably delivered across different servers even when the sender and the receiver are on the separate systems. In the third scenario, Alice needs to prepare and send her message using user agent. Once the message is ready, it must be sent over the LAN or WAN. This is accomplished using a pair of message transfer agents, a client message transfer agent and a server message transfer agent. Here is how the process works. Whenever Alice has a message to send, she calls her user agent, which then invokes message transfer client. The message transfer client establishes a connection with the message transfer server at her site, which is running continuously to handle incoming requests. The system at Ali's site queues all the messages in a buffer while waiting to be transferred. The message transfer client then send the queue messages to the system at the POP sites. Upon the arrival, the system at POP sites store the messages in his mailbox, making it ready for retrieval via his user agent. This scenario demonstrates the end-to-end message transfer using MTAs, ensuring messages are reliably delivered across networks from sender to receiver. In the fourth scenario, POP is connected to mail server via LAN or WAN, and he needs to retrieve the messages that have arrived. To accomplish this, POP uses a separate set of client-server agents known as message access agents. POP uses an message access agent client to request his messages. The MAA server, which is always running on the mail server, receives the request and transfers the message to POP's client. It is important to note that POP cannot directly access the mail transfer access server to retrieve mail. If he were to use the MTA server directly, he would need to keep it running continuously because the server cannot predict when a new message will arrive. This setup ensures that messages are reliably retrieved on demand without requiring continuous operation of the MTA server for every receiver. In email systems, there are two key approaches for transferring messages: push and pull. Push. The MTA client server model is a push system. Here the client pushes messages to the server whenever there is mail to be sent. The sender initiates the transfer and the server simply receives the incoming messages. Pull. POP as a receiver requests a pull mechanism. He uses message access agents which allow the client to pull the message from the server. In this approach, the client initiates the request and retrieve messages on demand rather than waiting for the server to push them. An electronic mail system is made up of several key components that work together to ensure reliable and efficient communication over the networks. User agent provides services directly to the user for composing, sending, and receiving messages. Handles email addresses, mailing lists, and message organization. Message transfer agent responsible for moving messages from the sender's mail server to the receiver mail server. It operates using a push mechanism, transferring messages whenever they are ready. Message access agent allows the receiver to retrieve messages from their mail server. It operates using a pull mechanism where the client requests message on demand. Mail store or system mailbox, a storage area on the mail server where messages are kept until user retrieves them. It ensures that messages are safely stored and accessible at any time. Email protocols. Protocols like SMTP, POP3, and IMAP govern how messages are sent, transferred, and accessed. Together, these components form a robust and reliable email system, enabling users to communicate efficiently across networks and the internet. Communication in SMTP is based on a simple exchange of commands and responses. The MTA client sends a command to a MTA server indicating actions like sending a message, specifying the sender, or defining the receiver. The MTA server responds with a status code confirming whether the command was successful or if an error occurred. This command response mechanism ensures that messages are reliably transferred between servers, providing a clear and organized flow of communication in the email delivery process. The first step in SMTP communication is connection establishment between the client and the server. When the server is ready to receive email, it sends the response code 222 to the client indicating readiness. The client then sends a hello command identifying itself with its domain name address. This step is essential to let the server know the origin of the request. The server acknowledges the client's identification with the response code 250, signaling that the connection has been successfully established and the client can proceed with sending mail. This handshake ensures that both the client and the server are aware of each other before any messages are transmitted. In SMTP, after the connection is established, the client begins the process of sending a message. The client sends the mail from command, introducing the sender and providing the return mail address. This allows the server to know where to report any delivery issues. The server responds with a status code, typically 250, confirming acceptance. Next, the client sends the receive to command specifying the recipient's email address. The server responds with a code confirming that the receiver is valid. The client then sends the data command which initializes the transfer of the actual message content. The server responds with a code signaling that the client may start sending the message. The client transmits the contents of the message line by line. Each line is terminated with a two-character end of the line token, carriage return, and line feed. Once the message is completely sent, the server responds with a final status code to confirm that the message has been successfully received. This step-by-step process ensures that emails are accurately transferred from client to server in a reliable and standardized manner. Once the message has been successfully transferred, the SMTP client terminates the connection with the server. The client sends the quit command to indicate that it has finished sending mail. The server responds with the status code, usually 221, confirming that the session is ending. After this exchange, the connection between the client and the server is closed, completing the email transfer process. This orderly termination ensures that resources are freed on both sides and the server is ready to handle new incoming connections. The first and second stage of mail delivery use SMTP. the Simple Mail Transfer Protocol to push message from the client to server. However, SMTP is not used in the third stage. Since SMTP is a push protocol, it cannot be used to retrieve message from the server. The third stage requires a pull protocol where the client activity retrieves message from the server. Here, the bulk of the message data flows from the server to the client. This stage uses a message access agent which enables the client to access and download messages. Currently, there are two main message access protocols: POP3 Post Office Protocol version 3 for simple download and local storage of emails, IMAP4 Internet Message Access Protocol version 4 for accessing and managing message while keeping them on the server, allowing synchronization across multiple devices. These protocols ensure that receiver can retrieve their emails efficiently, complementing the roles of the SMTP in sending messages. POP3 or Post Office Protocol version 3 allows users to download emails to their local device, often removing them from the server afterward. It is simple and efficient, making it suitable for users who access their email from a single device. IMAP4 or Internet Message Access Protocol version 4 enables users to access and manage emails directly at the server, supporting synchronization across multiple devices. This makes IMAP4 ideal for users who need flexible access from different locations or devices. In essence, POP3 focuses on local storage while IMAP4 provides server-side management and multi-device synchronization. Email has a simple structure and by default can send message only in NVT 7-bit ASCII format. This limitations means that non-ASCII data such as images, audio or special characters cannot be sent directly. To overcome this, the multipurpose Internet Mail Extensions MIME protocol is used. MIME enables the transmission of non-ASCII data through email by converting it into a format compatible with standard email systems. Here is how it works. At the sender side, MIME transforms the non-ASCII data into NVT ASCII format. The converted data is then delivered to the client MTA to be sent across the internet. At the receiving side, MIME reverses the process, transform the data back into original format, allowing the receiver to access the content as intended. MIME effectively extends email's capabilities, enabling the transmission of multimedia and complex data through standard email systems.